Right, so we're going to do a proof of the how to differentiate log. So we'll try to prove this formula. So when we differentiate log ln x, you get 1 over x. So to do that, we start with let y equal to ln x. Okay, ln x. Ln x. And then what you do is write ln x as log base ex, y like that. And then what we do is we're going to write it in index form. So we write it as x equal to e to the power of y. X equal to e to the power y. And then we're going to differentiate dx over dy. Because x is the subject, we write dx over dy. So when we differentiate exponential, what do we get? We get the same thing, e to the power y. Okay. Now, what's e to the power y? E to the power y is exactly x, isn't it? That's e to the power y. So I could replace e to the power y into x. And then we're going to continue dx over dy equal to x. We can reciprocal both sides. When we reciprocal, we become 1 over x becomes dy over dx. So that's a proof, which is not examinable, but if you see the proof, you know where the formula comes from. So the derivative of ln x is 1 over x. All right, any question? All right, no question. We're going to do some examples. All right, now there's two formulas. There's this one, ln x equal derivative of ln x is 1 over x. But what if there's a function inside the log? You write the derivative on the top over the original. Okay, this is on the formula sheet. On formula sheet. Okay, all right, let's apply these rules in the questions below. Starting with example 13. Okay, all right, differentiate the first one, dy over dx. So when there's a constant in front, you ignore it. And then it times by derivative 1 over ln x is 1 over x. Okay, so the answer is 2 over x. Yeah. All right, how about the next one? The next one is y dash equal derivative of 4x is just 4. Derivative of log base ex, which is ln x, is 1 over x. So you write 3 times 1 over x. So the answer is 4 minus 3 over x. All good? No question? All right, the next one requires you to use this formula, the one here, f dash of x over fx. So to differentiate log of this function, where your function is f of x, is 3x minus 5. The derivative of that will be just 3. So when we differentiate log of a function, it's going to be f dash of x over fx. Over fx. And what's f dash of x? 3 over the original function. Okay. Okay, any questions? No? All right, let's continue. Y dash, the next one. So you don't have to do that step each time. You can just do it in your head. X squared plus 1, write that in the denominator. Find the derivative of the denominator, which is 2x. And the derivative of 4 is 0. Done. And then you just write 2x over x squared plus 1. All right, continue. All right, after we finish, we have to look at the next question. Now, what rule do we use for the next one? product rule because it's x multiplied by ln x. So we have to use product rule. So write down u is x, v equal to ln x, u dash is 1, v dash is 1 over x. And then we use the product rule. Product rule, y dash equal to u dash v plus uv dash. And then u dash is 1 times x plus ln x times 1 on x. And then we'll continue. 1 times x is x. It's not right. I think, yeah, u dash. Yes. Okay. Let's try again. Okay, u dash is 1 times ln x plus u x times 1 on x. All right, okay. And then ln x plus x times x is cancel, and you end up with 1. All right, that's good. Okay, we'll continue. All right, what rule do we use for the next one? Quotient rule. So hopefully you remember u is x, v equal to ln x. It's the same thing except you write it as a fraction. So u dash is 1, v dash is 1 on x. So you write y dash equal to u dash v minus uv dash over v squared. And then u dash is 1 multiplied by ln x minus u, which is x times 1 on x, over ln x squared. And then things get cancelled, so x and x get cancelled, you get 1 ln x over ln x squared in brackets. All right, any question? Okay. All right, all good. We'll do 2 more pages, then we can give you back the exam. Just 2 more pages. 2 more pages. Okay, next page. Quiet, please. Okay. Next one, you use the same rule. So to find the derivative, copy the 2x in the denominator, then differentiate the denominator, which is 2. And then what happened to the 2? They get cancelled, so you get 1 over x. Okay, pretty easy. And the same rule for the next one. Y dash, just copy the function x squared, what's inside the log. Differentiate x squared, which is 2x. And we have to cancel the x and the x squared. Cancel, cancel. So you end up with 2 over x. Okay. All right, let's continue now. How about the next one? Ln square root of x. So that would take a long time because you have to write that as x power half. And then you're going to differentiate. So you go y dash equal to put the x power half at the bottom. Differentiate x power half, which is half, x power of negative half. And then we have to simplify it. So to simplify, we have to write half. The negative half is 1 over root x. The bottom is root x. Like this. And then to get rid of the denominator, get rid of the fraction in the numerator, so you times top and bottom by 2 root x. 2 root x. Let me write this again, didn't work out. Times by 2 root x. Okay, why do I do this? Because I want to cancel the fraction in the numerator and the root x. Right? At the end, 20 minutes. Okay. Okay, all right. So we're going to cancel, so you get 1 over 2 root x squared, which is just 2x. which is very, very long. And the question is there a faster way? Fortunately, there is a faster way, but you just have to use the log law you learned last term. Okay, let's look at method 2. So it is not recommended you use method 1 because it's very long. You will make a mistake and it's unnecessary. How do we use method 2? Now, by using log law, let me write down the function again, ln x power half. With the log law, what could we do with the half? We can bring it down, right? And when we bring it down, it becomes much easier to differentiate because I don't have to differentiate square root. So when we do y dash, you just go half multiplied by the derivative of ln x. What's the derivative of ln x? 1 over x, which is 1 over 2x, as we got earlier, in much faster way, right? So use log law to simplify. That will save you a lot of time. All right, any questions? So use log law, bring the half down, then differentiate. Okay, let's continue. How about the next one? Use the log law again, because every time you see square root, write it as x plus 4 to the power of half. And then to make it easier, bring the half down. Remember, this is not derivative. Sorry, I did it wrong. This is still y. Y is half ln x plus 4. This is just log law. Right, log law. And then you differentiate, and you can just ignore the half. And using the differentiation rule, write down the denominator, copy it, differentiate the denominator, which is 1. And the answer is 1 over 2 bracket x plus 4. Okay, question. Right, try the next few, see if you can use the log law. That will make it very easy. Okay, try the next one. Next one's at the bottom. So again, see there's a power there. You can bring it down. That will make it easier. Okay, let's do that. So we do, again, this is still y using log law, 6 ln x plus 6. That. When we differentiate, we can just ignore the constant, which is 6 times 1 over x plus 6. And then you get 6 over x plus 6. Now be very careful that this trick doesn't always work, because the next one, you can't use log law because it's cubing the whole log. So you can't just bring the 3 down. So instead, you have to differentiate straight away using the chain rule. See the difference between them? Very different. This is the power. When the power is inside the log, you can bring it down. But when it's outside the log, you can't use the log law. You have to use the chain rule. So the chain rule says, bring the 3 down, power 2. Bring the 3 down, subtract the power by 1. You get 3 something, power 2. Whatever inside the bracket, do not change. So whatever inside stay the same, ln x minus 4. And after that, you have to differentiate what's inside the bracket, which is 1 over x. So you get 3 bracket ln x minus 4 squared over x. Why is it over x? Because derivative of 4 is 0. Yeah? So yeah, 1 over x minus 0. So if I just keep that extra step, yeah, like that, derivative of inside. Right? So differentiate the power, then differentiate inside. Alright, think about that. Okay. We've got one more page to go through, then you will get your exam very, very soon. One more page. Yeah, you want both or you just want one? It's up to you. Alright. Let's go through the next one. Okay, next one, you can use log law as well. You can split into 2. So split into 2 plus ln x plus x minus 5. And you can just differentiate each one, so you don't have to expand the brackets. So do y dash equal 2 over 2x plus 1 plus 1 over x minus 5, using the rule we just discussed. Okay, how about the next one? You can, instead of using quotient rule, you can just minus them using log, right? Then you don't have to use quotient rule. Remember, this is still y using the log law. Then we differentiate, which is 1 over x minus 3 minus 1 over x plus 3. Okay, and then we've got one more question on equation of normal. Okay, you should have a try. I think you can all do it with no problem. Really easy. All right. Find the exact equation of normal to the line, to the curve at the point where x equal to 5. Okay. So what you need to do is to differentiate first. Y dash is 1 over x. Find the gradient of the tangent, which is when we substitute x equal to 5, 1 over 5. Then the gradient of the normal will be the negative reciprocal of 1/5, which is negative 5. Okay, now we need to get the point. Now to get the point, we have to substitute x equal to 5 in, y equal to ln 5. So the point is 5 ln 5. Remember, you need to leave it in exact form. So you do point gradient form, like that. Then you do y minus x1, which is 5. Oh no, y1, which is ln 5, equal to the gradient, negative 5, x minus 5. And then you just expand and make y the subject, so negative 5x plus 25. And then move the ln 5 over, so you get negative 5x plus 25 plus ln 5. Okay, good. Any questions? So today's exercise is exercise 4.7. 4.7, okay.